Good morning, folks. So this is what you're looking at is the solution to the exit ticket from yesterday's Google form. So I believe this was the equation that was put in the Google form. It asked for a couple pieces of information. First, it asked for what orientation was the ellipse, whether it was vertical or horizontal. That's a quick bit of info to pull as long as you know what to look for. The larger denominator is always going to kind of tell you what direction the ellipse is oriented. So the larger denominator is with the y, that's the vertical coordinate. So it has to be a vertical ellipse, all right? Just look at the larger denominator is the easy way to tell. The center, which I don't think I asked directly for the center, but it is always useful to know, is your h and your k, just like we saw in the circle equation. So -1 and +2, with respect to the x and the y, become your center for this ellipse. So even though I didn't directly ask for the center, if you recall all of our definitions, they're all points that are measured from the center. A vertex is A units away from the center. A co-vertex is B units away from the center. A focus is C units away from the center. So even if I don't ask for this, you still need to figure it out before moving forward. So I did ask for both vertices. So I need my value of A. Well, again, a lot of definitions at work here. We know A squared is always the larger denominator. It doesn't have to be with X. It doesn't have to be with Y. It's always whichever one of these is the larger. So A squared is 25, making A 5. And again, A is the distance from your center to a vertex. This is kind of like those points that are farthest from the center. They are the longer diameter of the ellipse. So because it's vertical again, I'm going to go A units up and down from the center. So I'm simply adding 5 and subtracting 5 units to the y coordinate, again, vertical coordinate, and that's where I end up with these two ordered pairs. Okay? So today we're only going to do one example. It's going to be pretty darn comprehensive though. So I am going to give you an equation for an ellipse and I'm going to ask for all this information. We're going to move very quickly once we do some work with this equation. So you're going to notice it's not in standard form. It's not even close to in standard form. This kind of might remind you of when we had a circle equation not in standard form. So we have to do a little work. We have to complete the square yet again. Every section is going to have some completing the square problem. So the first thing I want to do is I'm going to rearrange some terms. I'm going to get my x terms together. I'm going to get my y terms together. And I'm going to move this constant over to the other side. Whether it's positive or negative, I'm moving it to the other side of my equation. And now I have a -64. Now, in standard form, we didn't have coefficients in front of our x squareds and y squareds. So what I'm going to do is for each of those two groups of variables, I'm going to factor out whatever that leading coefficient is. So I'm taking a 4 out of the x's, and I'm going to leave a blank space there because that's where I need to still complete my square. And I'm going to do the same thing with the y's now. So I'm going to factor out that 9 leading coefficient, and I'm going to have a y squared plus 4y plus, and again, I'm going to leave a little blank there, and I still have my -64. So those blanks that I left there for space, those are going to be that third term I need to add. So again, remember, it's your middle term, half that squared. So half of -8 is -4. -4 squared is 16. Okay, and we do need a balance over here, but here's the trick. I'm adding 16, but that 16 is still getting multiplied by this 4. So when I balance this out, I need to add 4 times 16 over here. All right, otherwise it's not going to be a balanced equation. Let's see that again, but with the y's now. Okay, so again, I need this third term here. I'm going to take half the middle term squared. Half of 4 is 2. 2 squared is 4. And again, I need to balance my equation. So when I add to the other side, I'm not adding just 4, I'm going to add 9 times 4 because that 9 is being multiplied by the 4 we created. So now what does that leave us? Well, it's negative 64 plus 4 times 16 plus 9 times 4. That all comes out to be 36 on the right side. So it's not a terrible number to deal with. Here, we've balanced these two factors to make them nicely groupable into one binomial squared. This is going to break up into an x minus 4 and an x minus 4, and this is going to break into a y plus 2, y plus 2. Okay, so again, we have that 4 that we factored out in front and an x minus 4 quantity squared now. And on the y's, we have the 9 that we took out and a y plus 2 quantity squared now. Almost there, we see it kind of starting to take shape, but like I mentioned before, we don't want these coefficients here. Furthermore, in standard form, this needs to be set equal to 1. So I'm going to divide everything by whatever that number is. 36, 112, pi, doesn't matter. Divide by whatever that is to kind of force fit the number 1 on this right side. But if I divide this by 36, I need to divide everything by 36. Technically, I'm dividing the whole term, but it's really just the number in front that's going to reduce. And you notice 4 over 36 actually reduces nicely. That's 1 over 9. So I don't really need the 1, but I'm going to put the 9 there. 9 over 36, that reduces again pretty nicely to 1 over 4. So I don't need the 1 in the numerator, which is good, but I'm going to leave the 4 in the denominator. Finally, we have something that looks like a standard form equation. Not only that, we can start telling a lot of our information over here and filling it in. So for instance, my center is going to be positive 4, negative 2. Because the larger denominator now is underneath the x term, this is going to be a horizontal ellipse. Okay, now we're still going to look for the larger one for a squared, so a squared equals 9, so a equals 3, all right? That's now going to go left and right 3 units to find my vertices. Again, I'm going left and right because it's horizontal, right? There's a lot of connections to be making here. So my vertices are going to be 3 units to the left of my center, which would put me at 1 comma negative 2. All I'm doing is subtracting 3 from the x coordinate. And the other one is going to be 3 units to the right of my center. So now I'm going to add 3 units to that point, and I get 7, negative 2. Okay? We still need our co-vertices. Well, that's where my b term comes into place. So I'm going to look at the smaller denominator now. B squared equals 4, which implies b equals 2. Now, because I already moved horizontally to get to the vertices, your co-vertices are going to be vertical from the center. So this is the other direction we're going to move in. So this is going to affect the y coordinate this time. I'm going to go up and down 2 units from my center again. So if I go up 2 units here, I'm adding 2 units to the y. I'm going to have 4 comma 0. And the other co-vertex is going to be 2 units down. So I'm going to subtract 2 units from the y coordinate. And I have 4 comma negative 4. Now, the foci, your 2 focus points, are c units away from your center. And you might not remember this because it's been all the way back from Friday. We have this kind of little secondary equation here. A squared minus b squared equals c squared. It's not necessarily evident in your standard form. There's no c directly in this equation, but your a squared and your b squared are your 2 denominators. So in this case, you're simply going to subtract them. So 9 minus 4 equals c squared. So c squared equals 5. So c is radical 5. So radical 5, that's how far away from the center point either of the two focus points are. Okay? So those are going to be horizontal. Again, it follows the same pattern as the vertices, but I'm only going to go radical 5 or square root of 5 units. Now, you can round this if you want. I'm going to be exact, so I'm going to leave it as 4 plus the square root of 5, and the y-coordinate stays the same. And the other one is very simply 4 minus the square root of 5, and I'm going to leave the y-coordinate the same. Okay? So again, those foci, we have a horizontal ellipse. Here's my first focus, vertice, excuse me. Here's my second vertice. All right, here's my center. Those foci are going to be not necessarily perfectly in between. It's not like a midpoint, but they are certainly inside of the major axis. They're inside of the ellipse, okay? If you recall from the video on Friday, those are the ones that kind of help us form the ellipse in the first place from the definition, okay? So I'm going to spend again another day, maybe even 2 more on this in addition to today's lesson because it is very heavy with a lot of definitions. So I just want to give you time to work with them and be as comfortable with them as possible before we talk about a quiz. So I'm thinking Wednesday, maybe Thursday at the latest, based on whatever feedback I get from you guys today. I'll make a decision and I'll let you know tomorrow when that next little mini quiz is going to be. Good luck. Keep working on the homework. Reach out if you have questions.